Good morning, students. Welcome to your maths class. In the last class, you had learned 7 axioms of Euclid, and again I wanted to recall. Yes, here it is. Axiom 1 says that things which are equal to the same thing are equal to one another. And axiom 2 states that if equals are added to equals, then the wholes are equal. And axiom 3 states that if equals are subtracted from equals, then the remainders are equal. And axiom 4 states that things which coincide with one another are equal to one another. Axiom 5 states that the whole is always greater than its part. And axiom 6 states that things which are double of the same things are equal to one another. And in the last axiom, that axiom 7 in your syllabus, yes, things which are halves of the same things are equal to one another. These all are the 7 axioms that you had learnt in your last class. Now in today's class, let us discuss Euclid's 5 postulates. Children, tell me now, what is this that you are looking on the screen? Yes, this is the representation of a point, isn't it? Now tell me, yes, here it is, and another point that I have taken. Now tell me, how many lines can be drawn from this point, that is, this one point? Yes, you know that many lines can be drawn from a point A, isn't it? And now I am going to draw as many as lines as possible from point A like this. Yes, here I have drawn the line AE and AF like this. Now tell me, here how many lines passing through A also passes through B? Yes, only one. That is line AB. And how many lines passing through B also pass through A? Yes, good. Only one. That is also AB. So, can we say a straight line may be drawn from any one point to any another point? Yes. And this statement is Euclid's postulate number 1. Yes, children. I hope you understood. Postulate 1 says that a straight line may be drawn from any one point to any other point. And this statement is self-evident and so can be also taken as an axiom. Now tell me, children, what is this? Yes, this is a line and it can be extended on both sides. I want to represent its two endpoints here. This is the endpoint B and this is the endpoint of A. And now the same line becomes the line segment, isn't it? First, it was a line, simple line, but now it ended by 2 points like A and B. So the same line now become a line segment. And Euclid called this line segment as terminated lines. Yes. This is called as a terminated line according to Euclid. Now tell me, children, whether this line segment can be extended on either sides? Yes, of course, a line segment can be extended on either side to form a line like this. Here, I extended this line further from point B like this, and also from point A it extended further, isn't it? This is what postulate 2 says, that a line segment can be extended on either side to form a line. This is our postulate 2. It states that a terminated line can be produced indefinitely. Okay, let us move on to our next postulate. Children, how can we construct a circle? Yes, here I am going to construct circle. For that I need one point that could be point of center, like this. Now I have taken one point here and this is the center of the circle, and I need one radius, and here it is. I am taking one radius here. Let me name it as AB, and this is the point that could be the center of the circle, and AB is the radius that could be the radius of the circle. By using this center and this radius, I want to construct one circle now. Yes, let me do it. Yes, I constructed one circle from AB, through center A and from AB radius, isn't it? So can we conclude like this? A circle can be drawn with any center and any radius. Yes, a circle can be constructed with any center and any radius. This is what postulate 3 says. Postulate 3 says that a circle can be drawn with any center and any radius. In the next postulate, Euclid states that all right angles are equal to one another. Okay, let us look on it. Here, I have taken different right angles. Yes, these all are some right angles. Now, I want to superimpose all these right angles on one right angle. Yes. These all are some right angled triangles, and you know that angle ABC is right angle here, and angle DEF, GHE are some right angles, isn't it? Now I am going to superimpose these right angles on one angle, that is angle ABC. Do you think I will succeed? Yes, let me do first. Here. Now I am going to superimpose this right angle DEF on right angle ABC. Yes, I succeeded. I superimposed. Again, I want this right angle, that is right angle GHI. Yes, I am going to superimpose. Yes. This is also superimposed. All angles are now superimposed. Children, now tell me, how these right angles get superimposed? Yes, they are identical. So they get superimposed. And you know that if things are if things are identical, then they are equal, isn't it? This is what postulate 4 says, that all right angles are equal to one another. Children, postulate 4 says that all right angles are equal to one another. I hope you understood postulate 4. Let us move on to our 5th postulate of Euclid. Yes, children, postulate 5 is far more complex than any other postulate. On the other hand, postulates 1 through 4 are so simple, and these are taken as self-evident truths, because it is not possible to prove them. So these statements are accepted without any proof. Because of its complexity, you should give more attention to the 5th postulate. Okay? Are you ready for 5th postulate? Yes, here it is. If a straight line falling on 2 straight lines make the interior angles on the same side of it taken together less than 2 right angles, means less than 180 degree, then the 2 straight lines, if produced indefinitely, meet on that side on which the sum of angle is less than 2 right angles, means sum of angle is less than less than 180 degree. You understood? No, children? Okay, let me explain it further. Here, I have taken two lines AB and CD. If another line, that is EF, falls on line AB and CD, now observe, here, four angles are formed inside of these rays. No? Here, at G and at H. 1, 2, 3, 4 angles are formed. These angles we called it as a interior angle. And you know that this AB and CD are the two lines. EF is the line which cuts these two lines AB and CD at the point G and H respectively. So this point G and H we called it as a point of intersection, and the line EF we called it as a transversal. Okay, children. So now here I want to measure the angle of this AGH. You know why? Yes, according to our postulate, it says that if the sum of the interior angles on the same side of this transversal, means this line here, should be less than 180 degrees, and to intersect these two lines, the sum of these two angles should be less than 290 degrees or less than 180 degree. No? So, I want to measure the angle AGH now. Let me do now. Here, I am measuring the angle AGH. Yes, this is 91.7 degree. And also, I want the angle of GHC. Yes, this is 73.3 degree. Now, I want to add these two angles. I have added these two angles. I took 91.7 degree as 92 degree and 73.3 degree as 72 degree. Yes, the sum of these two angles becomes 164 degree and it is less than 180 degree, and means it is less than two right angles. So, according to your postulate, it says that if a straight line, this is a straight line, falling on two straight lines, that is AB and CD, makes the interior angles on the same side of it. Yes, these two angles. Together less than, if these two angles are less than two right angles, means less than 180 degree. Yes, here it is less than 180 degree. Then the two straight lines, these two straight lines, if produced indefinitely, if we produce it further, it will meet at some point. Okay, are you understood? Okay, let me check it. I want to extend this line AB now. Okay, let us do. Yes, I extended. And the line AB and CD intersected at the point R here. Sorry, K. Isn't it? So this is what your postulate number 5 says. I think you understood, children. Postulate 5 says that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angle is less than two right angles. I hope you understood postulate 5. Now I am going to wind up my class. Okay, postulate. In the next class, you are going to study what a consistent mean and proposition or theorems means. Okay. Thank you, children.